Hey guys, so let's start. So, dependency inject inversion versus dependency injection, right? So, first of all, it's to be honest, like it's not fair to use this versus itself here because we are not going to compare these two things actually. So, the reason is dependency inversion and dependency injection, they are like completely two different things. So, let me explain. So, you take any software development, ideally. You're gonna have multiple layers or modules. To be honest, like layers in your code base, right? So let's say uh, you have layer one, layer two, and layer three. So the dependency inversion is nothing but the high level module or layer shouldn't depend on lower level layers or module, however you call it. So in this case, the L3 shouldn't depend on L2, and then the L2 shouldn't depend on L1. As simple as that. Dependency inversion is that's it. So what do I mean by like shouldn't depend, right? Because ideally, to go a little deeper, you take any software development, again, business rules, and then you have your use cases and repository stuffs, and then you have your outermost layer, which is which will be like your actual framework or UI layer. So this is your UI, and this is your let's call it as like repository, and let's call it this as domain, which is like entities. So in this case, the UI shouldn't uh, directly depend on this repository layer, and then the same repository shouldn't directly depend on the domain layer, which is like the entities and use cases stuffs. So theoretically, this is enough. We know that what is dependency inversion, but how we going to achieve it is where the dependency injection comes in. So I told you guys earlier, dependency inversion is one of the principle in the solid design principles. So SOLID, where this D is DIP, which is dependency inversion principle. And how are we going to achieve this is using dependency injection. So that is why I told you guys that it's not fair to compare these two things. This is a principle, this is a technique. So we achieve this principle using this technique. Okay. So having said that, if you are someone from mobile app background, be it Android or iOS, I can quickly demonstrate a Swift code base, which is like almost similar to Kotlin, so it will be easy for you to understand. And if you are someone from non-mobile background, I'm gonna do a Python program which gonna demonstrate the same stuff. So yeah, let's jump in. So let's say I'm building a system where I have to send email notification to the customers. So to do that, I need an email service, right? So class email service, and to send the or to ask the email service to send the email, I need a class called notification. And inside this notification class, let obviously I need the instance of this email service. So private let email service equal to email service. Now, inside this notification, I also need to have a method called func send or trigger email with message string. and inside here, this method called email service. So inside the email service, I'm going to write a method called func send message, and I'm just like gonna do a debug print here. We don't care like how the email is being sent. So sending email with the received message, and here uh, we just have to call email service dot send. Done. Now how are we gonna consume it? Let notification equal to notification. Wow. And then call notification dot trigger email with this message. So now if you run it, you can see that sending email with the hello world, right? So whatever the message like I passed here, it came here and then like supplied. Now all this is like cool, fine, okay. Now let's say you want to write a unit test case for this class, and and you want to like unit test this particular method. Like how are you going to achieve it, right? Because this class has a strong coupling with this email service, which means at any given point of time when you call this trigger email method, it is going to actually like trigger the email, and which is wrong, right? In a like let's say when you test things, it shouldn't actually send the notification to the users. Instead, you should just have to mock it. And let's say today, like you have email service, but like let's say tomorrow, for some reason, you want to change from email to SMS notifications. Like, what are you gonna do it? Again, you're gonna like change all these things. So that's not the right way to do it, right? So the right solution to do is what I'm going to do is I'm just like going to comment all these things. Now, we talked about email service. Instead of class, I'm going to keep it as a protocol, which is nothing but interface in Java. And if you are from Python, like this is like abstract classes or whatever. So protocol email service, and it's gonna have a method definition, sorry, declaration called func send uh, message of type string. Done. Now we actually need the implementation. We have to implement this somewhere, right? So class email service implementation, which implements this email service. And obviously it's going to have the send with this message, and it's just like going to send this. Now, what I'm going to do is I'm going to create a class called notification, and here private let email service, which is of type email service and not the email service implementation. I'm just like going to keep it as the protocol here. So, and here func send message string, oh, sorry, email service dot send. Actually, let's call it as trigger. So I'm going to keep a constructor to initialize this. Now here I'm going to let notification equal to notification, and I'm supplying this actual implementation of this email service to this class. Now no, you call notification dot send and hello, and you will get sending email with the message hello. Now, the good thing about this is, let's say instead of email, you wanna send what like the SMS. So I just like wrote this for the demonstration purpose. So ideally, when you do a production grade coding, this will be like called as notification service, right? And then you just have to create one more class called SMS service implementation, which extends notification service, which gonna trigger the actual SMS notifications. And then if you wanna use the SMS, then um, let's call this thing as email notification, and let SMS notification equal to notification. Again, this parameter name is wrong. So notification service, and then notification with notification service as SMS service implementation. And now you just have to call SMS notification dot send. Come on. No, it's sending SMS with the hello. So in this way, as you can see here, this notification class doesn't depend or directly depend on this SMS service implementation or email service implementation. In this case, these are all the inner level classes, and this is the higher level classes. So this higher level class doesn't directly depend on the inner level classes. Instead, it communicates with these classes via interface or protocol. So you can just like swap however you want it. So this thing, what we are doing here is called dependency injection. This class depends on email service and okay, again, not the right name, notification. This class needs a notification service, and we are just like providing it here. We are just injecting this instance actually. So this is called constructor injection. There are couple of other ways you can inject the dependencies. One is method injection, the other one is like property injection. But Personally, I always prefer constructor injection because in this way, initialization makes sure that it needs or it gets whatever it requires to function properly. Because like if you're having a, a method injection or a property injection, then it's the caller's responsibility to properly like assign those or supply those dependencies, which is like error prone, right? So just for uh, just for example, if you don't want to have the constructor injection, then maybe what we can do is um, um, set notification service and self dot notification service equal to service, and then sorry, it's the job of this notification or the caller to assign the right um, assign or supply the dependency for this notification class. So if you are forgetting to do this, then obviously it's gonna crash. So that is why I kind of always prefer the constructor injection. That's it about the dependency inversion and the dependency injection. So just to summarize, dependency inversion is one of the principle in the solid design principles, and how you're going to achieve is using the dependency injection, right? So let's try to replicate the same thing on the Python. So let's create a class called email service, which is going to have a method called send email, which going to take a parameter called message, and when you get the message, you're just gonna print it, sending email message. So now you have the email service class. Next thing what we have to do is class notification, and it's gonna have a method called, or it's gonna have a property called email service, right? So to do that, def init so this notification class needs to have a reference of this email service. So to do that, we're gonna have the constructor for this notification. So init self, and we need self dot email service equal to email service. And once you have this, we're gonna need another method called def trigger message, and we're gonna call self dot email service dot send email with the received message. Okay, that's it. Now we need to create the instance of this notification class. So email service equal to, or sorry, email notification equal to notification. And once you create it, email notification dot trigger, supply the message hello. And how are we gonna execute this thing? Um, just so you know that I'm not a actual Python guy, so I'm just like trying my best here. Um, yeah, okay. Python 3. Uh, Let me cd into that. Python 3 di dot py. So as you can see, sending email hello comes, right? Now the same problem. If you wanna mock test this, or if you wanna supply, or if you wanna use the SMS service, this is not possible. So the good practice is that first we need to import the abstract base class, so which is available in the ABC module. So from ABC module, import ABC abstract base class, and then we also need abstract method actually. Then go and create a class called email, I mean not email, notification service, which is of type ABC, which is like abstract base class. And then it's gonna have a definition called send notification, which gonna take a message and then just pass it. And most importantly, you have to mark this method as abstract method. Now, once you are ready with this, go ahead and then create a class called email notification service, which is of type notification service, which means obviously this class is supposed to implement, provide the actual implementation for this method. So def send notification self message, print sending email notification message, and then next I'm going to create class SMS notification service, again which is of type notification service, def send self comma message, and then print um, what sending SMS message. Now once you have this, you need to create a class called notification, and inside that you need to have the notification service instance, right? So def init self dot notification service equal to, actually it shouldn't be like this, self comma service, which is of type notification service, and self dot notification service equal to this received service. And once you have it, have another method called send, not send, trigger, which takes message as parameter, and self dot notification service dot send notification with the received message. Now you can create email email notification equal to notification, and you need to pass the service which is um, email notification service, and then email notification dot trigger hello Python. Now run this. What's the problem? Manage the abstract class email notification with abstract method. Then notification. Okay. I had this method name wrong here. So run it. Hello Python. Now same way, SMS notification equal to notification. You don't have to mention service also, I think. So you just have to call SMS notification service, create the instance of that class, and SMS notification dot trigger from SMS service, right? So in this way, the high-level class notification doesn't directly depend on the actual implementations of the email notification service and SMS notification service. Instead, it depends on an abstract class which acts as a bridge to communicate with the actual implementations. So this is how we achieve dependency inversion principle using the dependency injection, which is like happening here. So I hope this tutorial helped you to better understand what is dependency inversion and like how we achieve it. And I know like there are folks like who have asked how we can implement a full dependency injection mechanism for a mobile application development, which is my next tutorial. So yeah, if you like this video, please feel free to subscribe, and I will see you in the next video. Thank you.